So in today's wraparound lesson, we're going to be looking at scientific notation and how do we write numbers in scientific notation, how do we take numbers that are in scientific notation, write them back into standard form, operations, word problems, just kind of all of it together. So we're going to start by writing numbers in scientific notation. Remember that scientific notation is always written as some number times 10 to the exponent. The reason it's times 10 to an exponent is the 10 is representing place value, and the exponent is telling us pretty much how many place values we're moving, because place values are based out of 10. What you want to do with scientific notation is we're going to have the decimal point currently, right now, it's after this last zero. We want to move the decimal point so that there is only one non-zero number in front of it. So I want to move the decimal point as far forward as I can so that there is only one number that is not a zero in front of it. In my answer, it's always going to be times 10, so I'm going to go ahead and write that first. Now I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. I had to move the decimal 9 place values, and I used the loops to kind of help me count as I go. We are not counting zeros, we are counting place values. So now in front of the multiplication sign, we write every number until we hit the long row of zeros. So I actually would not need that last zero on there. It would just be 1.06. Number 2, same sort of thing. It's going to be times 10. Our decimal point is here, and we're going to count backwards this time. 1, 2, 3, 4, 5. And we're going to stop right between the 4 and the 5. So it's going to be 4.5 out in front. This time, because we went backwards, our exponent's going to be negative, because it's telling us we went in the backwards direction. Let's see. Down to the next one. So now I have a number in scientific notation. I know it's kind of blurry. I'm going to write it a little bit better for us. It's 3.03 times 10 to the 4th. Hopefully it's clear on your paper. I'm going to write the number in front. I'm going to recopy that down. Now if I have a positive exponent, I'm going to go to the right. If my exponent is negative, I'm going to move to the left. So I'm going to move 4 places to the right because my 4 is positive. 1, 2, 3, 4. Any of the open spots, that's where I'm going to plug zeros in. The last thing I would like you to do is I'd like you to take the number, once you have it finally written, and write it all nice and neat and put the commas in where they belong, all of that. At this point, I'm going to have the teacher pause the video. I'm going to ask you to go through the rest of the problems on your own, see how you do, and then I'll come back and go over the answers to those. So now that you've had a few minutes, we'll go over the rest of the problems, just kind of quickly going down over the answers. So this one was 2.23 times 10 to the negative 6th. So 2.23. Because it's a negative exponent, I'm going to be moving to the left. 1, 2, 3, 4, 5, 6. All the open loops I fill in with zeros. Final answer written all nice and neat. 5 zeros and then the 223. 5, 6, 7, and 8 were the operations with exponents. In scientific notation, we're going to multiply our numbers like normal, the 4.4 and the 1.5. That gives us 6.6. We're going to add the exponents that are with the tens. So that's a 3 and a negative 7. So 3 plus negative 7 gives me 10 to the negative 4th power. Problem 6, I multiply the 7.3 and the 5.8, and that gives me 42.34. Add my exponents, that's times 10 to the negative third. I'm only ever allowed one number in front of the decimal point. And right now I actually have two numbers in front of that decimal point. So therefore, I need to move this decimal forward one place to give me 4.234. Because I moved the decimal point forward one place, I need to add 1 onto my exponent. So my final answer is 4.234 times 10 to the negative second. 7, we're going to do the same sort of thing, but now we're going to be dividing and subtracting our exponents. So I'm going to do 5.4 divided by 1.8. When I do that, I get 3. And I'm going to subtract my exponents, and I'm going to write it out so you can see it. It's going to be negative 5 minus a negative 2. Make sure you watch your signs. This goes plus positive, which means my final answer is 3 times 10 to the negative third. 8, kind of following along the same idea, divide the numbers. When I divide the numbers, I get 0.5 times 10 to the negative fourth when I subtract my exponents. I need to move my decimal point back one place, so I have one number in front of it. Because I moved it back one place, I need to subtract 1 or add negative 1 to my exponent, giving me 5 times 10 to the negative fifth as my final answer. Looks like problem 9 got cut off a little bit, but that's okay. We have enough room. We have the box that contains 5 times 10 to the third paper clips, and also in the problem it tells you that each paper clip has a mass of 8 times 10 to the negative fourth. If we want the combined mass or the total mass, we're going to want to multiply. Remember, with scientific notation, your choices are either multiplication or division. As soon as you see that word combined, it should indicate that we're going to multiply. So multiply my numbers. 5 times 8 gives me 40. I'm going to add my exponents. 3 plus negative 4 gives me 10 to the negative first. The problem is I still have two numbers in front of that decimal point. So I'm going to move the decimal point forward 1, which means I need to add 1 to my exponent. That gives me 4.0 times 10 to the 0 power, and that's fine. Or 4.0 times 10 to the 0 power is just 4. That would be okay as well. Obviously, if we just did a multiplication one, chances are this one's a division one. The word average should kind of clue you in that this one's going to be worked on with division. So we have 4 times 10 to the 9th divided by 5 times 10 to the 7th. I always split it in half so I know what I'm working with. 4 divided by 5 gives me 0.8. Subtract my exponents, that gives me times 10 to the second. My decimal point needs to move back 1, so I need to subtract 1 from my exponent, or add negative 1, so that gives me 8 times 10 to the first power. So if you have any questions on scientific notation, please feel free to let me know. I'm more than happy to help you, but that's kind of the overview of scientific notation.